So I will negative cosine AX over A. We need that to be in front of us. So it becomes what? Negative cosine 3 theta over 3 plus C. Well, I'm not going to write C right now. Okay. I know. I need to put C here, but for right now, I'm not writing. I got everything. You see that? I got F, G, F prime, and G. Now let's follow the rule. So let's follow the rule. F. What is F? 1/3 E 2 theta cosine 3 theta plus 2 over 9 E to the power of 2 theta sine 3 theta. Now we done. Just need to divide by 13 over 9. So integration of this one sine 3 theta d theta. This one divided by 13 over 9, which is times 9 over 13. So I just write it like that. Make sense, yeah?
Yep.
Now you can add C plus C. Du is then 4x cubed dx. du. Oh, sorry, dx, my bad. dx. Now let's substitute. You see, this one, if you put it together like here, this is du. And you can write it like this. You can write it as 1 over x to the power of 4 plus 7. I mean, that's, if I'm a starter, beginner, I will do it like this. Then I can see it. Oh, it looks like this. I just bring this one out. Now, this 1 over u, and then du. Oh, beautiful. This is so easy. I know how to integrate this one. This is ln. So it's just ln absolute value of u plus c. But it was not in terms of. If I write this one back like this, a root, and then you put what, u here, yeah?
Yep.
And then you have dx. But we want this one. We have dx, but we don't have 7. That's what I said, magic. So what magic? We can do whatever we want. I'll put 7 here. Why not? There you go. Solve. But then put 1 over 7 outside. Make sense? Mm-hmm. That's the magic. So then it becomes equal to 1 over 7 root u, and then 7 dx is du. Back to our notes. How do we integrate root?
Just change it to exponent.
Over 3, and then to the power of 3 over 2, like that, plus c. So this one equals, at the end, it becomes what? 2, and then this is a root if I want to bring it back. U was 7x plus 9, but now to the power of 3, and then 7 times 3 is 21, then plus c. Done. Make sense?
Yep. Du.
Mm-hmm.
Oh, no, we don't need du. I'm done.
That's we needed, yeah. I changed du because we integrated.
Okay. I usually leave it as exponent, but I mean it's the same thing.
Yeah, you can do that. But if you want to like evaluate like area under the
yeah, then you need it.
Yes,
because it's difficult evaluating with the exponent.
Because usually the point, if it's a real problem, I need to do it like that. But if you have a scientific calculator, it doesn't matter. But that scares me, like to the power of fraction. It's like, what is that? But when I write it like this, oh, it's root and then to the power of 3. Next example is, and then I have, for some reason, pi over x, then ln x dx.
Oh. Pi.
Yeah.
Wait, but pi is a constant, so.
Yeah, pi is a constant. You can just bring it out. So you can just write it pi, as you said. You can write it pi, and then ln 1 over, and also you can break this one, 1 over x times 1 over ln x dx. You see what I did?
Yeah.
Now we want u and du. I will use u to be ln x.
Yeah, okay.
And then du is 1 over x, yeah? dx. Okay, let's see what will happen if we substitute. So if I substitute now, that becomes pi, and then 1 over x is like this. I will write it like 1 over ln x, then 1 over x dx. If I write it like this, then it's more obvious. So 1 over ln x, it becomes 1 over u. 1 over x dx is du. Okay. Now we know how to integrate 1 over x. Do you remember from the notes, 1 is absolute value of?
Yeah, so ln.
Absolute value of ln, yeah. U plus c, so it's pi ln absolute value of ln x again plus c. This is ln of ln x. This is absolute value. Yeah. Cool.